Moving on to the first sum. In triangle ABC, right angle at B, AB is equal to 24 centimeters, BC is equal to 7 centimeters. Determine sine A, cos A, sine C, cos C. Moving on to the solution. Let us consider triangle ABC, which is right angle at B. Here AB is equal to 24 centimeters and BC is equal to 7 centimeters. Let us also find the hypotenuse AC. From Pythagoras Theorem, we know that the square of hypotenuse is equal to sum of squares of other two sides in a right angle triangle, which implies AC square is equal to AB square, which is 24 square, plus BC square, which is nothing but 7 square. That implies AC square is equal to 24 square, which is nothing but 576, plus 7 square, which is nothing but 49. That will be equal to 576 plus 49 is nothing but 625. That implies as AC square is equal to 625, AC is equal to square root of 625, which is nothing but 25. Therefore, we got the hypotenuse as 25 centimeters. Now, in the first problem, he asked us to find the value of sine A. We know that sine of an angle is equal to opposite side by hypotenuse, which is equal to opposite side is BC here by hypotenuse is AC here. That is equal to BC is given as 7 centimeters and AC is given as 25 centimeters, which is equal to 7 by 25. Now he also asked us to find the cos A. Here we know that cos of an angle is equal to adjacent side by hypotenuse, which is equal to, here adjacent side is AB for angle A and hypotenuse is AC, which is equal to 24 centimeters by 25 centimeters. That is equal to 24 by 25. Now moving on to the second bit. He asked us to find the value of sine C. We know that sine of an angle is opposite side by hypotenuse. The side opposite to angle C is here AB by hypotenuse is AC, which is equal to 24 centimeters is AB and 25 centimeters is AC, which is equal to 24 by 25. Now he also asked us to find the value of cos C. That is equal to, we know that cos of an angle is adjacent side by hypotenuse. Here the adjacent side of angle C is BC by the hypotenuse is AC, which is equal to BC is 7 centimeters by AC, that is hypotenuse 25 centimeters, which will be equal to 7 by 25 is the cos C. Moving on to the third sum. If sine A is equal to 3 by 4, calculate cos A and tan A. Now moving on to the solution. He has given the value of sine A, that is 3 by 4, and asked us to find the value of cos A and the value of tan A. For this, let us consider a right angle triangle ABC, which is right angle at B, and let angle AB set an angle and C is also the angle of the triangle ABC. Here he has given that sine A is equal to 3 by 4, which is nothing but, we know that sine of angle is nothing but the ratio of its opposite side by hypotenuse. Here the opposite side of angle A is BC by the hypotenuse in this triangle is AC. Therefore, we can write BC as 3 here and hypotenuse AC as 4. In order to find the values of cos A and tan A, we also need the adjacent side of angle A, that is nothing but AB. Here, by applying the Pythagoras theorem in triangle ABC, let us find the value of AB. By Pythagoras theorem, we know that the square of hypotenuse is equal to sum of squares of other two sides. Here we can write that AC square is equal to AB square plus BC square, which implies AC square here is 4 square, that is equal to AB square plus BC square, nothing but 3 square, that implies AB square is equal to 4 square, that is 16, minus 3 square, that is 9, which is equal to 7, which implies AB we get it as root 7. Now we got the AB value as root 7. Now he asked us to find the value of cos A. We know that cos of an angle is equal to the ratio of its adjacent side to the hypotenuse. We get cos A is equal to, here the adjacent side to angle A is AB by hypotenuse is AC, which is equal to AB, here we got it as root 7 by AC is 4. And he also asked us to find the value of tan A. We know that tan of an angle is its opposite side by adjacent side. Here the opposite side to angle A is BC by the adjacent side to angle A is AB, which is equal to 3 by root 7. Moving on to the fourth question. Given that 15 cot A is equal to 8, find sine A and secant A. Now moving on to the solution. Let us note on the given information that 15 cot A is equal to 8. That implies cot A is equal to 8 by 15. Let us assume a right angle triangle with A as base angle and B be 90 degrees and C be the other vertex of the triangle ABC. In this, he has given that cot A is equal to 8 by 15. We know that cot of an angle is nothing but the ratio of its adjacent side by opposite side. We can write cot A as the adjacent side of angle A is AB here by the opposite side of angle A here is BC, which is equal to 8 by 15. So here we can write AB as 8 and BC as 15. Now in order to get sine A and secant A, we need to find the value of AC, the hypotenuse. Now by applying the Pythagoras theorem to triangle ABC, we know that the hypotenuse square is equal to sum of squares of other two sides. Here we can write AC square is equal to AB square plus BC square. That implies AC square is equal to AB square, that is 8 square, plus BC square, that is 15 square, which is equal to 8 square is 64 plus 15 square is 225, that is equal to 289. So here we get the value of AC as square root of 289, which is equal to 17. So AC can be written as 17. Here firstly he asked us to find the value of sine A. We know that sine of an angle is equal to opposite side by hypotenuse here is equal to The opposite side of angle A is BC and hypotenuse here is AC, which is equal to BC is 15 and AC is 17. And in the second part he asked us to find secant A. We know that secant of an angle is equal to its hypotenuse by the adjacent side. So here the hypotenuse is AC by, and adjacent side here is AB for angle A, which is equal to AC is 17 and AB we got it as 8. Therefore secant A is equal to 17 by 8. Moving on to the fifth question. Given that secant theta is equal to 13 by 12, calculate all other trigonometric ratios. Now moving on to the solution. He has given that secant theta is equal to 13 by 12. So let us consider a right angle triangle in which theta is the base angle, and let us designate the sides as x, y, and let hypotenuse be z. Now we know that secant of an angle is equal to hypotenuse by adjacent side. Here the hypotenuse is nothing but z and the adjacent side of angle theta is y here. Now this can be got equated to secant theta, but he gave the secant theta value as 13 by 12. Therefore as z by y is equal to 13 by 12, let us assume that z is equal to 13 and y is equal to 12 in the simplest form. Now in order to find all other trigonometric values or trigonometric ratios, we need to find the other side, that is x. Now by applying the Pythagoras theorem to the triangle, we get z square, that is hypotenuse square, is equal to sum of squares of other two sides, that is x square plus y square, which implies z square here is 13 square, which is nothing but 169, that is equal to x square plus y square, which is nothing but 12 square, that is 144, which implies x square is equal to 169 minus 144, that is nothing but 25. As x square is equal to 25, we get x is equal to root of 25, which is nothing but 5. So we got the values of x, that is equal to 5, and y, which is equal to 12, and z is equal to 13. Let us find the all other trigonometric ratios. First of all, coming to the trigonometric ratio, that is sine theta, which is equal to, we know that sine of an angle is equal to opposite side by hypotenuse. Here it is opposite side is x by hypotenuse is z, which is equal to x is 5 and z is 13. And cos theta is equal to, we know that cos of an angle is nothing but its adjacent side by hypotenuse. Here the adjacent side is y and the hypotenuse is z, which is equal to y is 12 and z is 13. And let us also find the tan theta value, which is equal to, we know that tan of an angle is equal to its opposite side by adjacent side. Here the opposite side is x and adjacent side is y, which is equal to x is 5 and y is 12. Now let us also find the value of cot theta, which is equal to, we know that cot of an angle is equal to its adjacent side by opposite side. Adjacent side here is x, adjacent side here is y, and the opposite side here is x. which will be equal to, the y is 12 and x is 5, and also let us find the value of cosecant theta, which is nothing but the inverse of sine theta. Therefore cosecant theta can be written as 1 by sine theta, which is equal to 1 by sine theta value is 5 by 13. So 1 by 5 by 13 is 13 by 5. Moving on to the 10th question. In triangle PQR, right angle at Q, PR plus QR is equal to 25 centimeters and PQ is equal to 5 centimeters. Determine the values of sin P, cos P and tan P. Now moving on to the solution. He has given a right angle triangle PQR with right angle at Q, and he has given a relation between PR and QR, that is PR plus QR is equal to 25 centimeters, and he has also given the value of a side, that is PQ, as 5 centimeters. Now he asked us to determine the values of sin P, cos P and tan P. In order to determine the values of sin P, cos P and tan P, we need to find the sides QR, PQ and PR, as PQ is given and we need to find the value of QR and PR by the given relation, and we can also get another relation by applying the Pythagoras theorem to a triangle, that hypotenuse square PR square can be equal to sum of squares of other two sides, that is PQ square plus QR square. That implies PR square, let it be as it is, which is equal to PQ square is nothing but 5 square plus QR square, let it be as it is, which implies PR square is equal to 5 square, that is 25, plus QR square, which implies PR square minus QR square is equal to 25. That implies this is in the form of a square minus b square, which can be written as a plus b into a minus b. Therefore PR plus QR into PR minus QR, which is equal to 25. That implies PR plus QR is equal to 25 we have in the initial equation, that is 25 into PR minus QR is equal to 25, as on both sides of equality 25 is common, that can be got cancelled and it remains as 1 on right hand side. That implies PR minus QR is equal to 1. Let us name the first equation as number 1 and let us name this equation which we got as equation number 2. By solving this equation, that is PR plus QR is equal to 25 and PR minus QR is equal to 1, we get, so let us solve this. Let us add both the equations. We get 2 PR and this will be got cancelled, that will be equal to 26, and thereby we get PR is equal to 26 by 2, that is equal to 13, and similarly we get the value of QR by substituting PR in equation number 1, that is 13 plus QR is equal to 25, which implies QR is equal to 25 minus 13, that is 12. So here we got the values of QR, that is 12 centimeters and PR as 13 centimeters. So here we have all the sides of right angle triangle. Now we can find the values of sin P, cos P and tan P. Here he asked us to find the values of sin P, cos P and tan P. Let us find them. Initially, let us consider sin P. Sin P is equal to opposite side by hypotenuse. Here, the opposite side for angle P is QR by hypotenuse is PR, which is equal to QR is 12 centimeters and PR is 13 centimeters, which will be equal to 12 by 13. And cos P is equal to adjacent side by hypotenuse. Here, the adjacent side for angle P is PQ by hypotenuse is PR, which will be equal to PQ is 5 centimeters by PR is 13 centimeters. So finally cos P will be equal to 5 by 13. And he also asked us to find the value of tan P, which will be equal to opposite side by adjacent side. So that is equal to opposite side here is QR and adjacent side is PQ for angle P. That will be equal to QR is 12 centimeters by PQ is 5 centimeters, which is nothing but 12 by 5. Moving on to the 11th problem. State whether following are true or false and justify your answer. Moving on to the solution. Let us consider first bit. He has given that the value of tan A is always less than 1. It is false because the value of A corresponding to value 1 is 45 degrees. So as tan 0 to tan 90, the value increases from 0 to infinity. We can't say that the value of tan A is always less than 1. So the first statement is false. And moving on to second bit, he has given that secant A is equal to 12 by 5 for some value of angle A. That means he says that secant A value can be greater than 1. So we know that the value of secant A tends from 0 to infinity on varying of angle A. So this value can be satisfied for some angle of A in secant. So we can say that given statement is true. Now moving on to the third bit. Cos A is abbreviation used for cosecant of angle A. No, cos A is used for the cosine of angle. We can write that given statement is false, as cos A is used for the abbreviation of cosine. Now moving on to the fourth bit. Cot A is product of cot and A. It's false because we know that cot A is nothing but the ratio of adjacent side to the opposite side. We can't say it's a product of cot and A. Moving on to fifth bit. Given that sin theta is equal to 4 by 3 for some angle theta, this will be false because we know the sine value tends from just 0 to 1. It is minimum at theta equal to 0, that is value is 0, and at theta equal to 90 it is maximum and the value is 1. So the value can be 4 by 3.